What's good, people? Zensphere here with another Renoise tutorial. Today we're going to be taking a look at various approaches to DSP-based synthesis using the native DSP devices within Renoise. There's a lot of sound you can coax out of these devices if you know how to do it. And today we're going to dive in and explore exactly how it's done. So the first device we're going to take a look at is the ring modulator. And some of this information is out there, but some of you don't know it, some of you do. What we're going to do is we're just going to start with an empty instrument and we're going to create a waveform. And we just want one sample length because we basically just want the DC offset, which is this distance from the zero line. And so you take our draw tool and we're just going to do a maximum amplitude single cycle, one sample. And then we'll come into our effects section, create an effects chain, and open up the ring modulator. And now, when we press a key, we have our sine wave tied to the note value of the ring modulator DSP. Triangle wave, saw wave, square wave. We've got access to all four of these basic analog wave shapes through the ring modulator. So using this technique, we basically have turned Renoise into an analog emulation synthesizer. So let's look at some of the things that we can do with this. Now this is monophonic. If we try to play multiple notes at the same time, we just get a reinforcement of this same pitch value because this DSP device is not polyphonic. If we want polyphonic synthesis using a similar method, we can go through the modulation section and use the AM filters using this same technique, which is in fact more powerful. If you reference my video on sci-fi sounds using windowed sync synthesis, I go into that in some depth there, and you can see how that's done. But this is a little bit different technique, and we're just going to explore some of the pros and cons of it. So the first thing that we might want to do is get some movement across the keyboard. So for instance, right now, as I press different pitches, we're just going to hear this A4 tone coming out of our ring modulator. So if we slap a key tracker on there and select as the destination the ring modulator note value, and I believe we can just leave this as is. We then have, sorry, let me come up an octave here. We have our pitch values tied to our key press. And let's see, so this is not scaling correctly. So I think to actually make this scale correctly, we have to drop this down to the full range of the keyboard. So now see, when I press C5, we return C5 on the ring modulator. And we can turn the wet all the way up because we don't really need to hear that little DC offset click. So that's a little cleaner. Now, because this waveform is just a single sample and there's no window, there's no smoothing, we get these kind of nasty clicks. But fortunately, if we drop an envelope on here, that'll smooth out our sound. Okay, that's all well and good, nice and simple. But we can utilize some of these sliders, value sliders on the ring modulator DSP to introduce some variation into the sound. So for instance, this inertial slider can act like a portamento. So then we get some nice kind of drifty pseudo analog. One feature of analog synthesis is pitch drift to a greater or lesser degree depending on the synthesizer. Sometimes they drift quite a bit, sometimes it's just a subtle thing. And we could emulate that using our transpose knob here. And one way that we could do that would be to tie this transpose value to a macro here. And we'll just write this in here so that it's clear, transpose. And I don't think we want such a large range. Let's just do -1 semitones to 1 semitone here. And then we might want this value to kind of drift and flutter with each key press. So what I'm going to do, if you've watched my videos, this will probably come as no surprise. I'm going to insert a macro control doofer. My macro control doofer is available on my Gumroad if you're interested in acquiring it. You can make this yourself. It's basically just some key trackers running into LFOs, controlling the instrument macros device within the doofer. So we've got our transpose value here. Everything is turned on. Our key reset is going to trigger a new random value on each key press. So we've got some pitch drift. And it's sort of a subtle effect. We can turn it up if we want. We could also create some vibrato by using this transpose macro. Let's do this. Let's turn key tracking off. And let's turn frequency to, say, 4 lines per beat. It might be a little fast, but let's try it. And I think maybe we're... There we go. Maybe hear it. We could make this a little slower. Oops, not 80. 8. So this is all well and good. It's pretty basic, pretty simple stuff. Maybe not that interesting, but what we can do now is we could, for instance, maybe slap another ring modulator on there. Because we have this effects chain, and maybe we want this to key track as well. But let's have it key track in a way that's, say, different from our root note, so that we get maybe some inharmonic tones or just a little more complexity. Try changing up the waveform. And let's take this vibrato off here. It's a little much. So now we start to maybe get some more interesting tones here. So let's, instead of this transpose value, let's map this to macro 2. Oops, I'm sorry, that's not what I meant to do. Leave this one on transpose. We'll go to this one and map this to macro 2. And let's try 32. It's a little fast. Let's try 128. And let's bring this, let's just go down an octave. You know, it's not super fascinating, but it's maybe sort of interesting. And you can keep stacking ring modulators in this way, and key trackers and ring modulators, and build up some more complex types of sounds. Let's maybe change this note value and have this oscillate at a higher rate than the second ring modulator. Okay. Change the shape here. Some more random movement. So not super exciting, but you know, maybe something that's usable. Certainly fun to mess around with. You can stack the ring modulators so that they kind of operate harmonically, so they can be octaves or fifths of each other. There's a lot of different sound that you can kind of coax out of the engine just stacking ring modulators. I think I've got a whole series of ring modulator synths. Let's see if there's, this one's kind of interesting. This one has a couple running in parallel, although I think right now it's just one of them. You can see it has some nice movement to it. Sometimes it behaves unpredictably too, which is kind of nice. So it's worth experimenting with, I would say. Let's see if there's another interesting one here. This one. So yeah, there's some potential there, certainly. So that's some things that you can do with the ring modulator. Again, you know, experiment, play around with it, see what sounds good to you. Let's take a look at a different piece of DSP here. And let's see, I need a waveform. So I'm just going to drop in a little snip of white noise, which is often useful as kind of an excitatory waveform to just get some of these DSP moving. And I'm just going to turn this into an impulse. So just basically got a little click here that I'm going to use for my initial sound source. And let's take a look at the chorus device and some things that we can do with the chorus device. Now the chorus device is actually pretty powerful in terms of sound generation. One thing that is maybe a drawback to it is that we can't really freeze the modulation rate. So it's always going to be moving slightly. Although we can automate this reset function to effectively freeze it. But generally you're going to get some nice kind of self-oscillatory tones if you crank the feedback close to 100%. Let's try 99% and see how it sounds. This is a time-based effect, and so as far as I understand, it basically is a specialized delay unit. So we're kind of entering into karplus-strong synthesis territory here with this. And you can hear if you're listening in stereo, you can hear there's a pitch spread between the left and right signals. And you can modulate that using this phase parameter. And I think at 0 degrees, they're identical to each other. Depth can function as a pitch slider. Feedback can function as a sustain value. But we do need to be pretty close. Let's try 99.5%. And then delay can also have a relationship with pitch. Dry, wet, we can increase the signal. Depends on how much of that initial attack sound we want. And the character of the sound can change depending on what we're using as our excitatory impulse. So for instance, if we change this out with a sine wave, and we'll just use it non-oscillating, we'll just use it as a single cycle, you can hear it changes the character of the sound quite a bit. Softens it up. If we substitute in a triangle wave, again, we want no loop. It's a little harmonically richer. So feel free to experiment with different waveforms. I'm going to go back to the white noise because I like the kind of harmonic richness of it. So we'll just trim this down real quick. Oh, let's take it off looping. It's a different thing if you have it looping. Then you have kind of like a resonator effect. And that can be very interesting to explore as well. But for now, we'll just use this as an exciter. And let's see what we can do with this. We can obviously modulate different parameters through our macros using a macro control doofer. But I'm going to just keep it kind of all in the DSP chain by using my LFO bank doofer, which is also on my Gumroad if you're interested in it, if I can find it. This guy here, and we'll drag this chorus into the doofer here. And this way we have access to a whole bunch of LFOs that we can use to trigger values in this chorus device. So I'm going to set my target to chorus, and let's start out by modulating the depth. And these are just random LFOs. You can set them to whatever you want, but right now they're re-triggering on each key press with a random value, which can be a nice way just to generate some tones quickly. and you can hear the variety of tones that are available. So let's also modulate the delay parameter. And I don't think I want to go so deep. 69 milliseconds. I want to keep it under 20 milliseconds because that's kind of our audible pitch range. Or maybe it's more like 30, I can't remember exactly, but somewhere in that neighborhood. So then you could start, by, say, sequencing this and resampling it and picking out tones that you like, maybe using those as oscillators and doing some sound design from there, or you could use them as one-hits or percussion sounds. We can further affect this. Let's also modulate our phase parameter and see what starts to happen here. Now, of course, not everything needs to be random. But as I said, that's just kind of a simple, quick way to start getting some interesting tones. And again, if you're listening in stereo, you can hear that now that we're starting to modulate this phase parameter, we're getting a lot more stereo information, kind of more interesting tones. Some good kind of granular possibilities. You can see that the amplitude levels are pretty inconsistent, so you're going to want to do something to manage the dynamics here, probably some compression or limiting. I want to change my waveform a little bit so it's not such a harsh attack. So I'm just going to fade this in here. Fade it in even more. Kind of interesting. Let's hear what it sounds like if we turn the looping on. And let's throw a amplitude envelope on there. Now we're starting to get into some interesting territory. And to my ear, that's all usable, interesting sonic material. And we haven't even really touched the filter section here, which can also be pretty powerful. You can also introduce some of the modulation back into the signal. Get some interesting sort of dubstep mid basses serendipitously here. Like that sound. But generally, I'll like to freeze this and perhaps control the reset with an envelope. So let's see what that would look like. So if we say start tying LFO floor to chorus reset, and then open up custom and turn this to one shot. Well, it's already on one shot, but we need some speed here. Let's try 64 lines a second. And you can see that our reset triggers it on each key press. That's not fast enough. Let's try 32. And let's try a different shape here. That's kind of interesting to me. So you get the idea. You can tweak this in various ways. Let's check into our filter section, because this gives us all sorts of other sonic possibilities. If we want more kind of gooey, psychedelic, delay-driven madness, we can put a comb filter on top and crank up the feedback and modulate the note value. So let's do that. We're down to our 5th LFO, I think. And let's go to chorus and note. Let's just see how that behaves here. And I think I want to restrict the range so that it's lower in the range. So we'll turn the offset down quite a bit. You know, and of course the results are somewhat unpredictable because of all the random modulation, but you can really dial this in with some specificity if that's what you're after. But the basic idea here is that you can get some interesting sounds just out of the chorus unit. There's all these other filter types to choose from. I would say, like, you know, from vowel down, these all tend to be pretty interesting. Sometimes you got to crank the drive to really hear anything. And these values are probably going to be more audible on the higher end. Changes the timbre somewhat. So, you know, you can always experiment with that if you want to, you know, tamp it down. You can always throw a low pass on there. If you want to pull out the high frequencies, throw a high pass on there. You know how these things work, yeah? And then that's just that one chorus unit. Of course, we can further affect and process this and really create some interesting soundscapes from it. Resampling is always a good thing, or almost always a good thing anyway. It's nice to be able to kind of freeze some of this randomness and pick and choose interesting bits that you want to process further and use in kind of specific repeatable contexts. So that's the chorus unit. Let's look at the flanger and the phaser as well, because they also have some interesting potential to them. Again, these are our, you know, kind of our time-based effects. We looked at the delay unit back in the karplus-strong tutorial. Just check my channel if you're interested in that. So now we're after our flanger. So let's pull a flanger in here, and we can do the same sort of thing. Let's get an LFO bank. And let's drop our flanger into the LFO bank. And we can crank our rate down. This one we are able to freeze the movement of the flanger, which is cool. And I'm going to take this off of looping. And once again, the feedback is kind of the crucial thing here. That's what gives us some signal. Delay is going to correspond to pitch. Rate will give us movement. Amount you generally want to keep up. Feedback is going to be high. Amplitude, this just gives you more range to work with. So delay and rate are really the things that we have to play with, as well as phase. Phase is, I'd say, less audible on the flanger. But you can, take this free filter section into play. And I think I'm just going to drop a key tracker directly onto our delay. Now, shorter delay values correspond to higher pitches. So you're going to want to set your minimum above your maximum. And we'll go 30 milliseconds and 0 milliseconds. And I'm going to stretch this out across the keyboard. And I'm not particularly concerned with pitch values. If you are, check out Oops I Fly's key tracked doofers. I'm going to bump the feedback up to 99. So there's a lot of potential here as well. Again, the initial impulse is going to affect the sound pretty significantly. So there's a lot of potential here. Again, you can tie these values to modulators to have them change randomly or have them change in predictable ways. But you can coax some sound out of the flanger, and you can definitely coax some sound out of the phaser as well. The phaser is a nice one because it has kind of a different tone quality to it. It has this sort of glassy quality. Let's explore the phaser just a little bit. Again, we need to crank our feedback up. Negative feedback will give you kind of a different character to the sound. Let's crank up our stages, crank up our depth. Let's take our and let's just start assigning some randomness to this just to hear what kind of the range of tones are that we can coax out of the phaser device. Let's modulate depth. Let's modulate phase. And let's modulate reset as well as floor and ceiling. So this is, let's also modulate stages. We're just throwing everything at this just to hear. So you can hear there's quite a variety of tones that we're able to get. I'm going to bump this up. And I think it was a mistake to modulate the depth. I'm going to take that modulation off. We're going to keep the depth high. Sorry, lost track here. Get some nice, interesting, kind of glassy tones. So if you wanted to dial this in, you could really harvest some nice nice oscillators to use as waveforms to build instruments if you wanted pitched tonal instruments. There's a lot of sound to be harvested just from within these suite of time-based effects. And of course you can further process this, make it much more interesting, start using phrases to get some maybe more interesting movement. Right there, we've got something that's a little more interesting, sort of rhythmic, something that we could slap into a track. We'll just throw some basic effects on here. Throw a delay and reverb on there. And that's without any, dynamics processing. Obviously, these transients are pretty intense because of the white noise burst. But we could, again, use something different. So let's throw a sine wave in there. And let's turn the looping off. Becomes a little more gentle. I love watching the phase diagrams. Some wild stuff, which might cause some issues when you're mixing in mono. But you get the idea. There's a lot here. Let's try a saw wave, see how that sounds. And that's with the looping mode set to forward. So let's throw an envelope on there, tame this a little bit. Get some movement in the filter section. Now, obviously, we need to control the dynamics here because it's getting a little crazy. I'll throw a compressor on there. We'll throw a clipper on there too. You get the idea. There's all kinds of stuff you can do with this. It doesn't have to be so rhythmic. You could turn this into a pad really easily by just triggering one node and then resampling that and using that as a starting point for a new sound, so on and so forth. But I wanted to just give you a little quick tour of some of this DSP-based synthesis that you can do within Renoise using native devices. If you have any questions, feel free to shoot in the comments below. If you want to see anything else in particular in future videos, let me know. Happy to show you some stuff if I can. And yeah, check out my Gumroad. Some of these doofers are available there. I'm also offering Renoise lessons if you're interested in lessons one-on-one. you can hit me up through Gumroad. And yeah, that's what I got for you today. Go out there, make lots of music, and we'll catch you next time. Peace.